Hello students, my name is Dr. Ashutosh and in today's lecture we are going to discuss two very important topics of biomechanics, which is force distribution and pulley system. So let's start today's lecture. So first of all, we have already studied what is a force and what are the type of forces. We have read about the definition of the force in the last lecture, and also we have read about the type of forces which are external and internal force. If you have not watched that video, then you can click on the I button and see that video right now. So now let's start and understand what is a linear force system. So a linear, as you can say, or you can understand by the name also, that a linear force system is a force system which is occurring in only one plane. So this is a coplanar force system. Whenever two or more forces act on the same segment, in the same plane and in the same line also. So these all the things combine to become linear force system. As you can see in the diagram also, all the forces F1, F2, F3, F4 and F5, they are acting on the same segment as well as they are acting on the same plane. Also they are acting in a same line. So force in a linear force system are assigned positive or negative sign. They can be assigned positive or negative sign based on the direction. If the direction is opposite, you can sign any sign, like you can give any sign, positive or negative, in one direction, and if you have given the positive sign in that direction, then you have to give negative sign in the opposite direction. This is a very easy system. In a linear force system, vector must be collinear and coplanar. So that has to be there in a linear force system. Now, how will you determine the resultant linear forces? So to determine the resultant linear forces, the net effect or the resultant of all the forces that are part of that linear forces is determined by finding the arithmetic sum. You don't have to do much complex calculation, you just have to do an addition. So for example, a force is acting in this direction of 10 Newton and a force is acting on this direction of 20 Newton. So what you will do, you will take plus 10, you will take minus 20, because this is opposite to the direction of 10 Newton, and then you will add these two values and you will get the resultant linear force. It is very easy to find out the resultant linear force in this sort of system. Okay. I think I have cleared everything. Now moving on to the next system, which is a concurrent force system. This is a very important force system because we are going to see this force system in our body. Majority of the times we will study about the concurrent force system. So whenever two or more vectors applied to the same object, as you can see, the vectors, they are more than 2 in number, F1, F2, F3, F4, F5 in this picture, are not collinear. They are not collinear but converge. You can find them collinear because they are present in the same plane, okay, but the vectors are part of a concurrent force system, means they have a same point of origin. Remember, whenever we will talk about concurrent force system, they will have a same point of origin. So any two forces in a concurrent force system can be composed into a single resultant vector through a graphical process known as the law of parallelogram. We have already read about law of parallelogram in our earlier classes while we were in school. It might be 9th, 10th, 11th or 12th. So let's check it once again, what is a law of parallelogram by an example in our body. So as you can see in this picture, a person is sitting on the edge of a table and there is a weight which is attached to the shoe of that person. That weight is of 40 newtons, right? And gravity is also acting on that limb of 48 newtons. So the total force that is acting on in this situation is 88 newtons in the downward direction. Now, as you can see, that limb is not moving. The body is able to defend this 88 newtons. But from where the force is generating inside the body, from where the internal forces are generated. So majority of the forces are generated by the two vectors in this scenario, which is by anterior capsule of the knee and the posterior capsule of the knee. Anterior capsule is present in the anterior side, posterior capsule is present on the posterior side, and the resultant vector of both these forces are actually cancelling this 88 Newton of force. As you can see in this second image, this is anterior force vector, this is posterior force vector, and by the law of parallelogram. So what is a law of parallelogram? It states that to find the resultant vector you have to make a parallelogram. We all know what is a parallelogram. So what you need to do is you have to start, as you can see my pointer, the head of this force vector, you have to draw a parallel line. This line is parallel to this vector, which is anterior vector, as to make the parallelogram. Then from the head of the another vector you have to make a line which is parallel to the other vector. In this case it is by posterior capsule, and the point where both these two lines meet, you have to join it from the point of origin of these vectors. That is why I said you, to find the resultant in a concurrent force system, you need to have a same or common point of origin of these vectors. So as you can see, the total resultant vector in this case is 88 Newton, which is countering against the force of this gravity as well as the force of the weight, which is 40 plus 48, that is 88 Newtons. I hope this is clear to you. Now let's move on to the other slide, which states that it is always true that the magnitude of the resultant magnitude you are getting will always be less than the sum of the magnitude of the composing forces, which means that the resultant here is 88 Newtons, but the force, if you just add the force of ACL, or in this case is anterior capsule and posterior capsule, you will get more force, but they are acting at a certain angle. So that is why their force generating capacity has been reduced. So remember, always the resultant vector will have a magnitude which is less than the sum of the magnitude of the composing forces. In composition of the forces by parallelogram, the relative length has to be taken into consideration of the concurrent forces for the proper representation of the magnitude. As we all know, I assume that every one of you know that if we are representing a vector, this line is actually signifying the magnitude of the vector, and this arrow is telling us the direction. This is a very basic thing which I assume that you all must be knowing. Now this was all about the linear force system and also about concurrent force system and how to find out the resultant in linear force system. So in linear force system you just have to do summation of the forces, and in concurrent force system you have to find out the resultant force by using the law of parallelogram. Now let's move on to the other topic, which is a pulley. You all must have encountered with the pulley in your daily life. If not, you must have seen in the villages or in the movies that to pull out the water from the well, you need to pull the rope by attaching it to the pulley. So what is the role of attaching the pulley to pull out the bucket? The answer is very simple, that it is redirecting the force to lift the bucket. Also, it is making us easy to lift the weight, as it is really helpful in increasing the mechanical advantage, and how it does so we will see in the couple of slides now. So it is a simple wooden pulley, could be made up of wood, also it can also be made of a metallic structure, but nowadays plastic pulleys are also available in the market to carry small loads. The carrying capacity of the plastic pulleys obviously will be lesser than the metallic and the wooden ones. So there is one very peculiar thing about pulley, that this can be rotated freely about an axis which is passing through the center. So if you see over here in this diagram also, there is a pulley which has an axis passing through middle of it, and the pulley can rotate freely about this axis, which makes it really special for the person to pull the weight very easily, right? Now it can change the direction of force, which makes it much easier for the people to lift anything. As I told you earlier, it changes the direction of force. Now there are different pulleys according to the mechanical advantage. Basically, there are 5 type of pulleys with the maximum mechanical advantage you will see in the threefold purchase, which is this last one. So there are 3 ropes tied between these 2 pulleys, and this rope is extending from here freely, and if you will attach the weight and from here and pull it from this point, then it will be easy. If we are putting 10 Newton of force, then output force will be 6 Newton because the mechanical advantage is 6. That is the role of pulley. Actually, the role of pulley is to increase the mechanical advantage. In the earlier classes, we have already read about the mechanical advantage. Their formula is output force divided by input force, or mechanical advantage is equals to that internal momentum divided by external momentum. Now let's see very interesting thing, which is anatomical pulley. We are concerned for biomechanics of the body, and for that we must be aware about the anatomical pulley. So fibers of a muscle or a muscle's tendon wrap around a bone or deflected by a bony prominence. They can be deflected by a bony prominence, and in this case these bony prominences act as a pulley. So whenever the direction of pull of a muscle is altered, the bone, it can be altered by the bone, it can also be altered by the prominences of the bone, like you see acromion process this is a prominence of a scapula. These prominences cause the deflection and forms anatomical pulley. Pulley, if they are frictionless, change the direction without changing the magnitude of the applied force. If the pulleys are frictionless, means there are no friction in the pulley, they will change. If you are putting the force in this direction, they will change that direction to downward without changing the value of that force. But if friction comes in the picture, then the force will obviously reduce. Now let's see the pulleys in our body. So first example is of middle deltoid. We all know what is the function of a middle deltoid. We have read the anatomy. If not, I am telling you that middle deltoid is responsible for doing abduction of the shoulder joint. So middle deltoid will help in abduction. Now see very interesting thing over here, that is that humeral head of the humerus and acromion over here act as a pulley to increase the movement arm of this muscle. So this will be the scenario if there would have not been any pulley of acromion or humeral head. Then as you can see this arrow, this is the force by the muscle and this is the point of axis. Can you see there is very less distance between the line of action of the muscle and this axis? The moment arm is really very less, but this is not the case in our body. Actually, middle deltoid comes and wraps around the head of humerus as well as the acromion and inserts here in the deltoid tuberosity. So as you can see now, the moment arm of this muscle has been increased, and we know this from previous lecture that if internal moment arm of the muscle is more, then the muscle will produce more torque. The muscle's capability of producing more torque will be increased because the moment arm is increasing over here. So this is how the anatomical pulley help in the functioning of a muscle. Now let's understand this by seeing another very important muscle, which is quadriceps. We all know that quadriceps contract to produce the extension at the knee joint. If patella is not present, assume that patella is not present in our body. If patella would not have been present in our body, and I assume that you know the insertion of the quadriceps muscle, let me tell you once again. So quadriceps comes and attaches to the patella, then patella along with the ligamentum patellae attaches to the tibial tuberosity. This is the ideal scenario which is occurring inside our body. But if patella would not have been there, then you can see this is the moment arm that we would have got, because the muscle would have come from here and just above the tibiofemoral joint, it will contour a bit and then attaches to the tibial tuberosity. But now let's see what patella is actually doing. patella is increasing the distance between this axis and the perpendicular distance of the muscle's line of action, thereby increasing the momentum. So this is how patella is acting as an anatomical pulley. This is actually increasing the internal momentum by increasing the distance. So if patella is there, then the muscle has to make a larger contour before inserting to the tibial tuberosity. If it is making a larger contour here, patella will act as a pulley and it will increase the distance between the axis to the line of action of that muscle. I hope this is clear with you. Now let's understand this once again by this flowchart, that for knee joint extension, the joint axis is considered to be located through the femoral condyles. Actually, the joint axis in our body is never fixed. We will see that in upcoming lectures also. There is a concept of evolute that we will study in upcoming lectures. But consider for now that joint axis is at the femoral condyles. Now patella is embedded in the quadriceps tendon and it pushes the tendon away from the femur. Okay. Now patella, what patella is doing? It is changing the angle that patella tendon makes with the tibia. Here the tibia means tibial tuberosity, and changing the line of pull of the quadriceps muscle away from the knee joint axis. So it is taking the line of pull away from the knee joint, away from the axis. This effect of changing the line of pull of the quadriceps muscle on the tibia is to increase the momentum. Now, if momentum is increased, we all know that force will be increased, and if we are studying the angular motion, that force is called as torque, which means that muscle's capability of producing the torque will increase. So this is how the patella will act as an anatomical pulley. Now, in the same way that we studied in the earlier examples, Pisiform bone also act as a pulley for flexor carpi ulnaris tendon to glide over it. As you can see, this is a sesamoid bone. It does not have any attachment like patella also. More sesamoid bones in our body act as a pulley. This is their principal function. As you can see in this image, this red one is the pisiform bone. So flexor carpi ulnaris moves over it and attaches to, if you know, you can comment in the comment section box also. Flexor carpi ulnaris attaches to the fifth digit, base of the metacarpal of the fifth digit. Right? Now we have studied 3 examples. Now before ending this slide, we must know that sesamoid bone is equals to anatomical pulley. Each sesamoid bone has the similar effect of changing the direction. So this is very important for a pulley. It has to change the direction of a muscle or tendon action line. So that is why if it is changing the direction, then it is increasing the momentum, and then only it is increasing the torque. It increases the ability of a muscle to produce torque around one or more joint axes. Now, there is one more interesting example of changes to momentum of a force. So, as I told, momentum is always changing. This is an example of quadriceps extension. Assume a person is sitting on the edge of a table and he is doing extension of the limb with weights attached on the foot. Now he is doing extension. If you will try this at home, then you will find it difficult to lift the weight at the end range of extension. But why did this is occurring? This, I have added this concept in this PPT to combine the knowledge of this PPT and the knowledge of the previous lecture, and we have combined both of them to understand the phenomena that is occurring over here. So what is just happening in this slide? A person is doing extension with the balls attached at the foot. Now let's see where is the external momentum and where is the internal momentum. As you can see, this red line is the external momentum. It is the distance between the fulcrum and the external weight. Assume this is the center of gravity. This is the center of mass of this limb. So the perpendicular distance from this point to this point is the external momentum, and this black line is the distance between the perpendicular line of the muscle's action. In this case it is quadriceps and the fulcrum. So as you can see over here, the external momentum is larger than internal momentum. But if you will see in this case, now the external movement arm has increased more than earlier. Earlier its length was lesser, but now its length has been increased, but there has not been any considerable change in the quadriceps internal movement arm. That is why we assume that whenever we are doing the extension at the end range, as the external movement arm has been increased of that muscle, so it is difficult for us to lift the weight. So I hope this is clear with you that how the movement arm is changing with the force. So in this lecture we have read about the linear force system, we have read about concurrent force system, and also we have learned how to find the resultant in both these systems. We also looked through the pulley, what is a pulley, how it is helping in developing the mechanical advantages, and we have also seen the examples in our body. We have seen the anatomical pulleys of shoulder, we have seen of the knee, and also the how pisiform bone is acting as an anatomical pulley. And at the last we have seen how the movement arm is changing with the movement, right? So this was all for today's lecture. Thank you.